Hello everyone. Today we will be continuing our discussion of networks and trees with the concept of spanning trees. Now, we looked in the last video at this example network, except without all of these numbers on here. We'll explain what those are in a minute here. And this is an example of a network or a connected graph. Now, when we have networks like this, we can have something that's called a subtree. Now, a tree, if you remember from the last video, is basically just a network that does not contain any closed circuits. So, a subtree basically just means a tree that we make using edges from the full network graph. So, if we wanted to draw a subtree for this, one way that we could do this, for instance, would be just A to B, and then we could draw edges from B to C, D, and E. So this is a tree because there are no there are no circuits within this graph, and we are using only edges that already exist in this network. So that's an important thing. When you're drawing a subtree of a network, you can't just make up edges that don't already exist. Now, this brings us to the concept of spanning trees. Well, a spanning tree is basically just a subtree of the network that includes every vertex in that network. So if we wanted to make a spanning tree for this network, we could take this subtree that we already have and we can expand this so that it includes every vertex in the graph. So if we want to include vertex F, we have to have this edge EF in there, otherwise it's not going to be connected. Same thing going to G. And then we basically just need one edge going to every one of these other vertices. So we could have from F to H and I to J and K, and then from K to L. Notice once again, all of the edges that we used from this are edges that already exist in this other graph. So because we have made a tree that includes every vertex in our graph, this we would say is a spanning tree of our original network. Now, related to the concept of spanning trees is the concept of minimum and maximum spanning trees. This is where all of these numbers that we have drawn on the graph come in. So this is what we would call a weighted network, meaning every edge has some kind of value or weight associated with it. A minimum spanning tree is basically whatever spanning tree we can make for this network that has the lowest total weight. There is also such a thing as the maximum spanning tree, which is essentially the opposite. We have a spanning tree of this network, but instead of going for the lowest total weight, we're going for the highest total weight. Now in the next video, we will look at an algorithm that will allow us to find both the minimum and maximum spanning tree for this network. Thank you for watching, and as always, I'm happy to help with questions.